ఓకే, సో ఇక్కడ మీరు ఒకసారి అబ్జర్వ్ చేశారనుకోండి, దిస్ ఫస్ట్ ఎంట్రీ హ్యాస్ ద యూనిట్ లెంత్. మీరు కావాలంటే దాన్ని క్యాలిక్యులేట్ చేసుకోవచ్చు. సో దిస్ వన్ హ్యాస్ ద యూనిట్ లెంత్. దట్ వాల్యూ, whenever you apply that norm value, that value will become 1. And this only diagonal elements amma, indirect ga cheppalante the diagonal elements should have the length is equal to 1, and the remaining entries are there. Okay, remaining entries means this green color circles. Okay, these all entries are the orthogonal vectors if and only if the product value, inner product value equal to 0. That means you can take this value is equal to 0, this value is equal to 0, and 0 0 0 0. Only diagonal elements value equal to 1, and the remaining entries value is equal to 0. So therefore, since the entries of capital U are orthogonal and are of unit length, so entries of capital U are orthogonal and those all are of unit length. So therefore, the matrix capital U has orthonormal columns. Okay, so whenever capital U has orthonormal columns, what is that meaning amma? Orthonormal columns ante the columns of capital U are first of all orthogonal avvali. Okay, columns of any matrix first of all orthogonal, after that they are the unit vectors. Okay, unit vector means unit length anamata. So orthogonal avvali unit vectors aithe then they are called as orthonormal columns anamata. Now substituting the corresponding values in equation number 1, so we will get that U transpose into U is equal to, so this first inner product value equal to 1 aitadi, second value, third value 0, and here 0 1 0 0 0 1 according to the previous slide. So therefore that is equal to 1 0 0 0 1 0 0 0 1. It is a 3 by 3 identity matrix sum purely. Okay, so therefore the product value U transpose into U is equal to capital I. So these columns are called columns of identity matrix, that is equal to capital I. So therefore product of U transpose into U is equal to capital I. So this is the one of the important theorem in the orthonormal sets anamata. Along with this theorem we have more two more conditions also, that is norm of U into X is equal to norm X. Okay, so and we can also verify that norm of U into X is equal to norm U into norm X. Okay, so there are two more properties. Those two more properties are this one and this one. So we can calculate these values also in this format, in the similar format only, but these properties are not required for this theorem. Okay, so based on those properties we can discuss the next problem, that is the problem number 3. So let's start the problem number 3 amma. Here given matrix is capital U is equal to 1 by root 2 1 by root 2 and 2 by 3 minus 2 by 3 1 by 3. Here you can observe carefully, this capital U has orthonormal columns. First of all we have to check that condition. Okay, orthonormal columns, orthonormal columns. ఇక్కడ capital U అనే మ్యాట్రిక్స్ ఇచ్చాడు కదా, ఆ capital U మ్యాట్రిక్స్ యొక్క కాలమ్స్ వాట్ ఎవర్, దిస్ వన్ ఇస్ ద ఫస్ట్ కాలమ్ అండ్ దిస్ వన్ ఇస్ ద సెకండ్ కాలమ్, ఆ కాలమ్స్ మనకు ఆర్థోనార్మల్ కాలమ్స్ కదా మనం ఒకసారి చూడాలి. ఆర్థోనార్మల్ అంటే ఏమవ్వాలి, నామ్ వాల్యూ ఏమవ్వాలంటే మనకు 1 అవ్వాలి. సో ఫస్ట్ ఇక్కడ మనం ఒక క్రాస్ చెక్ చేద్దాం. చూడండి మీకు అర్థం అవ్వడం కోసం చెప్తున్నా ఇది. ఓకే, ఇట్ ఈస్ నాట్ ఇన్ ద పార్ట్ ఆఫ్ ద ఎక్స్ప్లెనేషన్, ఫర్ యువర్ అండర్స్టాండింగ్ ఓన్లీ. సో దేర్ఫోర్ హియర్ ద ఫస్ట్ కాలమ్, ద టోటల్ కాలమ్, ఫస్ట్ కాలమ్ లో ఫస్ట్ ఎంట్రీ ఈజ్ ఈక్వల్ టు, ఓకే, so we are finding that the norm of the first column, that is equal to, we can write in this format, under root of 1 by root 2 whole square plus second entry entamma, again 1 by root 2 we have 1 by root 2 whole square, third entry 0 square. Okay, so therefore you will get under root of, okay, so 1 by 2 plus 1 by 2 plus 0. So therefore under root of 2 by 2, so therefore root 1, therefore 1. Ante norm C1 is equal to, okay, norm C1 is equal to 1. అంటే ఫస్ట్ కాలం లెంత్ ఎంత వచ్చింది మనకు, ఈక్వల్ టు 1 వచ్చింది. దట్ ఈస్ కాల్డ్ ఆర్థోనార్మల్ కాలం. సో ఇక్కడ మీకు ఇదే స్లైడ్ లోనే, సేమ్ స్లైడ్ లోనే యూ కెన్ సీ హియర్ ద మ్యాట్రిక్స్ క్యాపిటల్ U హ్యాస్ ఆర్థోనార్మల్ కాలమ్స్. వాట్ ఈస్ దట్ మీనింగ్? ఓకే, ద ఎంట్రీస్ హియర్ యూ కెన్ సీ ద ఎంట్రీస్ ఆఫ్ మ్యాట్రిక్స్ క్యాపిటల్ U ఆర్ ఆర్థోగోనల్ and are of unit length. That entries are orthogonal and are of unit length. That means whenever you take the columns, that column satisfies the unit length condition. Similarly, you can also prove that the second column. Okay, so we can also take that the length of the second column length we can also find in this format. So 2 by 3 whole square plus minus 2 by 3 whole square plus 1 by 3 whole square. So therefore under root of 4 by 9 plus 4 by 9 plus 1 by 9. Okay, so therefore you will get under root of 9 by 9. So therefore root 1 that is equal to 1. అంటే ఈ సెకండ్ కాలం యొక్క లెంత్ కూడా మనకి ఎంత వచ్చింది? 1 వచ్చింది. అంటే whenever you find the length of the vectors in that column, that length is equal to 1 అయితే those columns are called orthonormal columns. మనకి స్టేట్మెంట్ లో కూడా చెప్పారు కదా, ఈ ప్రాబ్లం స్టేట్మెంట్ లోనే క్యాపిటల్ U has orthonormal columns అని. Compulsory we have to check that condition first of all. Okay, orthonormal column means for each and every column, if you take the first column, that length is equal to 1. If you take the second column C2, that length is equal to 1. If you take the third column, that length is equal to also 1. ఆ length మనం ఎలా ఫైండ్ అవుట్ చేస్తాం అనేది ఫార్ములా మీకు ఇక్కడ ఉంటుంది. సో దిస్ వన్ ఇస్ ద ఫార్ములా అండర్ రూట్ ఆఫ్ ద స్క్వేర్స్ ఆఫ్ సమ్ ఆఫ్ ద given values or given entries. So this is the explanation regarding the orthonormal column summa. So it is not in the part of your explanation, but for your understanding only I wrote here. So with this you have the clarity that okay, so that is the capital U. That capital U is capital U has orthonormal columns and small x is equal to root 2 and 3. So therefore consider the condition. What we have to prove? We have to verify, we have to find out the value of norm ux. Okay, so u into x, where u is the 3 by 2 matrix and x is the 2 by 1 matrix. So 2 to equal unnai kabatti, so we can apply the multiplication. Then with this row we can multiply this column, then you will get this value 1 by root 2 into root 2 plus 2 by 3 into 3. Next second row first column. Okay, second row first column. So therefore then you will get this value 1 by root 2 into root 2 minus 2 by 3 into 3. Next third row first column, third row first column. So therefore 0 into root 2 plus 1 by 3 into 3. So therefore if you cancel root to cancel amma ikkada 3 cancel, 1 by root to cancel, 3 cancel, 3 cancel, then you will get that 1 plus 2 that is 3. Next 1 minus 2 minus 1, 0 plus 1, 1. So therefore u into x is equal to 3 minus 1, 1. That is the vector. It is actually an orthogonal vector. So for that orthogonal vector, if you find that the norm length of that vector, norm ux is equal to formula this one amma. Direct formula under root of the sum of the squares of the entries in that column matrix. Okay, sum of the squares of the entries in that matrix. So that is the formula for that to find the length of the matrix. So therefore norm u into x is equal to 3 square plus 1 square plus 1 square ante manaki enta vastundamma 9 plus 1 plus 1 that is root 11. Okay, so that is root 11 is the length. Root 11 ante manam em cheptam 3 point something. Okay, so root 11 ante manaki emamma 3 point something, ఎందుకంటే రూట్ 16 మనకు 4 ఉంది, రూట్ 9 ఈక్వల్ టు 3 ఉంది, ఈ రెండింటి మధ్యలో బిట్వీన్ లో ఉంది కదా రూట్ 11 అనేది. సో దేర్ ఫోర్ మనం ఏమని చెప్తాం, అది 3 పాయింట్ సంథింగ్, వాట్ ఎవర్ ఇట్ మే బి, ఎగ్జాక్ట్ వాల్యూ అయితే మనకు 3 పాయింట్ లో ఉంటుంది. సో అట్లా లెంత్ ఆఫ్ దట్ వెక్టార్ ఈస్ 3 పాయింట్ సంథింగ్ అని చెప్పేస్తాం. సో నెక్స్ట్ కండిషన్ ఏంటంటే మనకు సిన్స్ స్మాల్ ఎక్స్ ఇస్ ఈక్వల్ టు రూట్ 2 3 we have, and length of the x value, length of the vector small x is equal to under root of 2 square plus 3 square. So 2 plus 9 again we have norm x is equal to root 11. So therefore norm ux equal to norm x. So that is the first condition. Okay, norm u into x is equal to norm x. So already I clearly explained. Okay, in the theorem we have three properties summa. U transpose into u is equal to capital I, that is the first condition, and the second condition is u into x is equal to norm x. U into x is equal to norm x, that is the second condition. So next second condition is u transpose into u is equal to, substitute that value of my u transpose, we are writing u transpose, already you have capital U. Okay, this one is the capital U value, that value we are writing here. So okay, transpose, whenever you apply the transpose, rows will become columns, columns will become rows, and capital U value. So therefore, if you do the multiplication, it is a 2 by 3 matrix and it is a 3 by 2 matrix. So we can apply the multiplication. Then for if you proceed this row, these two columns, and this row, these two columns, then if you proceed in this format, so you will get values in this format. 1 by 2 plus 1 by 2, 0, 0, 4 by 9 plus 4 by 9 plus 1 by 9. So therefore, if you simplify that values, 1 0 0 1, 1 0 0 1. So 1 0 0 1, it is a 2 by 2 identity matrix. Therefore, U transpose into U is equal to I. So previous ga second problem, ide lecture lone second problem lo what we have proved this condition. So for that theorem, so this is the problematic example. And total ga meeku orthonormal set avvalante ikkada manam discuss chesina each and every problem. Okay, problem number 3, okay, is total example for the orthonormal set. Okay, only we have given that definition of the orthonormal set. If you want the example, so you can give this problem only. Okay, if you get the question in the examination, otherwise no need. So in this format we can verify the orthonormal set conditions, definition, and problem based on this. So okay, so therefore this is the total explanation of this lecture. I hope you understood this lecture very well. So in the next lecture we are coming with next topics. Make a perfect practice, prepare well. Until bye, thank you.